right, you got this. Let's do amazing things. Keep going, you're on the right track.
Welcome to Snapshot Podcast. So usually when we talk about a medical diagnosis, there's this inherent expectation of precision.
Right, absolutely. It's very cut and dry.
Yeah, exactly. It feels engineered. Like you break your arm, you go in, the x-ray shows that jagged white line on the film, and the doctor just points to the illuminated screen and says, there it is. The world in that moment is comfortably binary. It's broken or it's not broken.
Yeah.
It's real or it's not real.
Right, because it's an objective shared reality. We inherently crave that kind of categorization, I think, because it gives us a baseline to operate from. You and the doctor, you're looking at the exact same physical truth.
But then, and this is what we're getting into today, you step into the landscape of modern digital reality, specifically the absolute explosion of augmented reality and special effects, and suddenly that x-ray machine just shatters.
Yeah, it really does.
The diagnostic landscape of what we are actually seeing through our screens is just incredibly murky now. I mean, the barrier to altering reality used to be so high that you almost always knew when you were looking at an illusion.
Right, because it looked fake or it looked expensive.
Exactly. But today, we're looking at a paradigm where that barrier has essentially evaporated. And it's culminating in this massive industry shakeup that we are going to do a deep dive into today, which is YouTube's brand new desktop-based effect maker for shorts.
I love how you phrase that, actually, diagnostic muddy waters, because we really are entering this era where the distinction between what is captured by a literal camera lens and what is computed by a graphics processor is it's disappearing.
It's totally vanishing.
But to truly grasp the magnitude of what YouTube is doing here, I mean, putting a professional-grade augmented reality engine directly into a web browser, we have to contextualize it. We have to look at the sheer physical effort it used to take to trick the human eye.
Oh, for sure. The history here is wild.
It is. If you look at the academic research on the history of special effects, the lengths that filmmakers went to before computers existed are staggering. And it basically divided into two camps, mechanical effects and optical effects.
Right. And I always think of the mechanical side as the brute force method.
That's a perfect way to describe it.
If you want a massive explosion on screen, you literally go buy explosives. If you want a monster, you pour, hundreds of pounds of latex into a mold, and you build a giant mechanical skeleton.
Yeah, it was entirely rooted in physics and heavy engineering. Mechanical effect, or practical effects, meant manipulating the actual physical environment right in front of the camera. The research points to classic examples like the James Bond Aston Martin.
Oh, the ejector seat.
Yes. That ejection seat wasn't drawn on film. Engineers had to build a pneumatically powered roof and a pressurized seat mechanism that could safely launch a real stuntman into the air.
Which is terrifying when you think about it.
Oh, incredibly dangerous. But the absolute pinnacle of this era, the one that really illustrates the insane capital required, is Stanley Kubrick's 2001 A Space Odyssey.
Oh man, the jogging scene.
Exactly. To simulate zero gravity for that jogging scene aboard the Discovery 1 spacecraft, they didn't just fake the camera angle or use wires. They had an engineering firm build a literal 30-ton rotating Ferris wheel.
30 tons?
A massive centrifuge. And the actor literally ran inside it while the camera was locked to the rotating axis.
The scale of that is almost incomprehensible today.
Right.
You are talking about millions of dollars, heavy industrial machinery, and genuine physical danger to the crew just to capture, a few minutes of an actor jogging in sweatpants.
Right. And if you couldn't build it in the real world, you had to rely on the second camp, which was optical effects. And this was where the manipulation happened not on the soundstage, but inside the camera itself, or, later in a darkroom.
Which brings us to the era of the optical printer, right?
Yes.
Which, from my understanding of the sources, sounds like an absolute nightmare of calibration.
Yeah. It was essentially a custom-built projector mechanically interlocked with a camera. So filmmakers would take a strip of film, say, a shot of an actor running in front of a blue screen, and they'd project it.
Okay.
Then they'd take another strip of film, maybe a matte painting of a futuristic city, and project that. And the camera would photograph the combined light of those projections frame by agonizing frame.
Wow.
It was this crazy chemical and optical symphony. If a single piece of dust landed on the film, or if Like the light bulb in the projector flickered even slightly,
Ernie.
completely destroyed. If the registration pins holding the film misaligned by a fraction of a millimeter, the illusion was gone. Like the Starship USS Enterprise flying through space, that was achieved through months of this painstaking, literal manipulation of light and celluloid.
So the historical bottleneck was always either massive capital investment in heavy engineering or this agonizingly slow, specialized chemical process.
Exactly.
Which totally explains why the industry just rushed toward computer-generated imagery. The second microprocessors became viable. I mean, it wasn't just directors wanting cooler aliens. It was the financial directors trying to stop hemorrhaging money.
Oh, absolutely. It was driven by the budget.
Because the source material brings up a great point. Simulating a 16th century castle or a sinking ocean liner on a hard drive is infinitely cheaper than laying actual brick or building a giant water tank in Mexico.
The shift to CGI was definitely a financial imperative disguised as an artistic revolution, but, it introduced a totally new kind of bottleneck. We moved from the physical danger of the soundstage to the intellectual intimidation of the software interface.
Right.
Which brings us to what we could call the After Effects era.
Adobe After Effects. It became the absolute gold standard for compositing, 2D animation, motion graphics, everything. But, I have always pushed back on the idea that software like this democratized filmmaking.
Really? How so?
Well, democratized the access to the tools, sure. But the process itself remained aggressively exclusive.
That is very true. The learning curve was, and honestly still is, essentially vertical. When you open legacy compositing software, you aren't greeted with a blank canvas to paint on. You're greeted with a database interface.
Yes. It looks like an Excel spreadsheet had a baby with a math textbook.
Exactly. You have timelines stretching across the bottom, this massive stack of nested layers, masking paths that require vector calculus to manipulate smoothly, and keyframes dictating motion over time, graph editors to manage the acceleration and deceleration of every single value.
It's overwhelming. The best analogy I can think of isn't even a professional pilot's cockpit. Because a cockpit implies you at least know what the vehicle's supposed to do, right?
Right, it's a plane.
Opening After Effects is like walking into a massive dark warehouse full of raw iron ore, some wiring, and a pile of rubber. And the software just says, okay, build the steering wheel, invent the combustion engine, and then you can drive to the grocery store.
That's a painfully accurate analogy.
You literally have to construct the underlying logic before you can make any art whatsoever.
And that's before you even consider the entire ecosystem it requires. The research notes that professional visual effects don't happen in a vacuum. After Effects is just one node in a massive pipeline.
Oh yeah, you need a whole suite of stuff.
Right. A professional creator is simultaneously running Adobe Premiere Pro to manage the actual cut, Cinema 4D to render complex polygonal lighting, Grass Valley EDIUS for broadcast-safe color space conforming, and Sony SoundForge Pro to ensure the audio sample rates perfectly match the frame rates.
So you're acting as your own IT department. You're your own systems architect. And somewhere in there, you're supposed to find time to be an artist. Beginners hit that wall incredibly fast.
They really do.
They watch a slick tutorial on YouTube. They download the software. They accidentally hit a hotkey that hides their timeline, and they just quit. The technical friction completely suffocates the creative spark.
Which is exactly the core problem the tech industry has been aggressively trying to solve for the last 5 years.
Yeah.
How do you take the mathematical power of a multi-software rendering pipeline and abstract it so completely that the user only interacts with the creative choices?
And that brings us to the mission of our deep dive today. What if you didn't need to understand vector paths or spline curves?
Right.
What if you didn't need thousands of dollars in software licenses or a literal rendering farm humming in your basement? What if you just needed a Chrome browser to alter reality in real time?
It's a huge shift.
We are witnessing a massive disruption driven by social augmented reality tools. And we need to explore how YouTube is aggressively pivoting to capture this space with Effect Maker. But to understand their strategy, we really have to look at the giants they were trying to topple first.
Absolutely, because the social AR space before YouTube's entry was essentially a triumvirate. 3 incredibly powerful, highly distinct platforms that were entirely dictating how billions of people interacted with augmented reality.
So let's break down the big 3.
Yeah.
Because anyone listening who has ever used a digital beauty filter or, put digital dog ears on their kid has interacted with the end product of these engines.
They definitely have.
First up, you have Meta's Spark AR.
Spark AR was basically the engine that powered the entire Instagram and Facebook ecosystem. If you look at its historical footprint, it defined the aesthetic of the late 2010s internet.
For sure. The whole influencer aesthetic.
Yes. It was heavily optimized for face tracking, beauty enhancement, and subtle environmental lighting. Brands absolutely flocked to it because Instagram is fundamentally a commerce and lifestyle platform. If a cosmetics company wanted to let users try on a new shade of lipstick digitally, they hired a Spark AR creator.
But from a technical standpoint, Spark AR was notoriously rigid, right? Like, I know they enforced a hard 4 megabyte file size limit for a really long time.
But it did, yeah.
And in the world of 3D modeling, 4 megabytes is practically nothing. It's tiny. You're basically forcing creators to compress textures until they bleed and strip out every unnecessary polygon just to get it to fit.
It was a huge constraint, but that limitation was born of necessity. Meta had to ensure these effects would load instantly on, like a 5-year-old smartphone in a rural area with a weak 3G connection.
Well, that makes sense. Because of the scroll?
Exactly. If an Instagram filter takes 10 seconds to load, the user just scrolls past it. So they push the optimization burden entirely onto the creator.
Okay, so Meta owns the brand-friendly, highly compressed beauty space. Then you have Snapchat's tool, Lens Studio, and this one seems to be the heavyweight champion in terms of raw capability.
Lens Studio is essentially a full-fledged game engine masquerading as a social media tool. As the Access Our Research details, it doesn't just do face tracking. It does complex hand tracking, full-body tracking, and world mesh generation.
Wait, world mesh generation, like mapping the room.
Exactly. The software uses the camera to map the physical geometry of your living room, so a digital ball can realistically bounce off your actual physical couch.
That's wild.
It is, but to access that kind of power, it demands a much higher baseline of technical literacy. It relies heavily on writing actual JavaScript for its complex logic.
Right, which brings the coding barrier back into play.
Yeah.
So then you have the disruptor that completely rewired how we consume short-form video. TikTok's Effect House.
Effect House was built with an entirely different philosophy. Where Lens Studio prioritized raw power, Effect House prioritized frictionless virality.
Because TikTok trends move so fast.
Exactly. TikTok understood that their platform thrives on rapid trend cycles. If a joke is funny on Tuesday, it's dead by Friday. So they designed a platform where a creator could ideate, build, and publish a simple visual joke, like stretching someone's forehead or placing a spinning meme above their head in less than an hour.
So we have 3 incredibly sophisticated, free pieces of software out there. But there is a massive structural flaw here for the creators themselves. It's the ultimate walled garden problem.
But silo problem, it is the defining frustration of the social AR industry right now.
Because, think about it. If I spend 3 weeks painstakingly building a beautifully interactive, augmented reality game in Snapchat's Lens Studio, and I want to share it with my audience on TikTok, I just can't.
No, you can't. There is no export to TikTok button.
Right. The underlying rendering architectures are entirely proprietary. I would have to open Effect House and literally rebuild the entire project from scratch, using different logic systems, different compression rules, a completely different interface.
Which forces creators to specialize. You become a Spark creator or a Lens creator, and this ties directly into the economics of survival in this industry. I mean, how do you monetize a skill set that is entirely tethered to a single corporation's ecosystem?
I would imagine it varies wildly depending on the platform's culture, right?
Entirely. Because Meta's Spark AR was so heavily integrated into Instagram's influencer culture, the monetization there was almost exclusively B2B business to business. Creators acted as independent agencies, charging major brands tens of thousands of dollars to build promotional effects for movie releases or fashion campaigns.
Whereas Snapchat seems to gamify the monetization a bit more.
They do. Lens Studio relies on the creator marketplace, which is essentially a matchmaking service connecting brands with verified AR artists. But they also inject massive amounts of capital through direct competitions. They'll offer huge cash bounties to creators who can build the most innovative lens using a newly released tracking feature, basically artificially stimulating the development of their platform.
And TikTok. Because TikTok feels entirely driven by the algorithm.
Which is incredibly lucrative if you hit the lottery. A TikTok effect can go globally viral, generating millions of videos in a weekend, even if the creator has, 10 followers. TikTok compensates through a creator fund based on usage metrics, but more importantly, that virality instantly transforms an unknown creator into a highly sought-after brand consultant.
But relying on a single corporate ecosystem for your livelihood is a massive risk, and that risk just violently materialized. The source material from the Lensless blog highlights this tectonic shift in the landscape. Meta is shutting down Spark AR. They're just pulling the plug.
It's really hard to overstate the psychological and economic impact of this within the AR community. Metaspark practically invented the commercial viability of social AR.
Yeah, they started it all.
And with one corporate memo, thousands of creators who spent years mastering the nuances of its patch editor, who built their entire client networks around Instagram filter deployment, suddenly saw their primary revenue stream just evaporate.
It's a brutal reminder that you don't own your audience or your tools when you build in a walled garden. When the landlord decides to demolish the building, your store goes down with it.
Exactly.
But in the world of tech, a vacuum that large doesn't stay empty for long. You have this massive cohort of highly skilled, suddenly orphaned AR engineers looking for a place to ply their trade. Enter YouTube.
YouTube launching Effect Maker right now is one of the most calculated strategic deployments we've seen in the creator economy in years.
So let's dissect their strategy.
Yeah.
Because the tube filter reporting throws out a number that is just hard to wrap your head around. YouTube Shorts is averaging 200 billion daily views.
200 billion, it's staggering.
That is a river of human attention. But historically, YouTube Shorts has had a massive imported content problem. I mean, you couldn't scroll for 2 minutes without seeing a video that was clearly filmed on TikTok using a TikTok effect, downloaded and re-uploaded to YouTube.
Right, and the visual watermark of a competitor on your platform is basically an admission of feature inferiority. YouTube recognized that they were acting as a secondary distribution hub rather than the primary point of creation. By launching Effect Maker, they are fundamentally altering their value proposition to creators. They are saying, we no longer just want to host your video. We want to own the entire pipeline of your creativity.
But their approach to the pipeline has a glaring quirk that I really want to challenge here. Because if I want to make a TikTok effect, I can do a lot of it right on my phone. But Effect Maker is currently exclusively a desktop-based tool.
Right.
You have to go to effects.youtube.com on a Chrome browser. Now, I understand that real-time 3D rendering requires heavy computational lifting, but doesn't locking it to a desktop kind of kill the spontaneous, mobile-first nature of short-form video?
I see why you'd think that, but it's a calculated trade-off. While mobile processors have become incredibly powerful, the interface real estate on a 6-inch screen is severely limiting when you are trying to manage spatial coordinates, asset libraries, and visual logic maps simultaneously.
Okay, that's fair. It gets cramped.
Very cramped. By forcing the creator onto a desktop browser utilizing WebGL architecture, YouTube is prioritizing the depth and quality of the effects over spontaneous creation. They want professional-grade tools, and you simply cannot manipulate a 3D environment efficiently with fat thumbs on a glass screen.
Okay, I'll concede the screen real estate argument, but I will not concede this next point because the barrier to entry seems wildly counterproductive to me. If you want to use Effect Maker, you have to unlock YouTube's advanced features.
Ah, yes, the two-step verification process.
It's not just a text message code. You literally have to pass a video verification looking into your webcam, nodding, turning your head so an algorithm can verify your biometric humanity, or you have to upload a photograph of your government-issued ID.
Like a driver's license or passport.
Exactly. To make a filter that puts digital sunglasses on a dog, that friction is massive. TikTok's Effect House is dominating precisely because a 14-year-old can download it and start building instantly. Isn't YouTube suffocating their own platform in the crib by demanding a passport?
If you view it purely as a user acquisition strategy, yes, it seems completely suicidal, but you have to view it through the lens of YouTube's core business model, which is high-value advertising.
Right, the ad revenue.
YouTube commands premium ad rates because they historically offer a more brand-safe environment than the chaotic frontier of TikTok.
So the friction is the feature.
Precisely. We are operating in an internet environment flooded by automated bot networks, generative AI spam farms, and malicious actors who just weaponize algorithms. The Google support documentation explicitly cites the need to prevent automated scripts from overwhelming their systems.
That makes sense.
If someone builds an AR effect that projects hate speech onto a user's face or creates an interactive game that violates safety policies, YouTube needs to know exactly, legally, who created it. By requiring a government ID, they're establishing a chain of accountability. They are deliberately sacrificing explosive, zero-friction user growth to build a highly curated, thoroughly verified, brand-safe, walled garden.
It's a fascinating philosophical difference. TikTok wants everyone to build everything, consequences be damned. YouTube wants fewer, but fully accountable architects.
Exactly.
Okay, so assuming I've handed over my biometrics and my passport, I am verified. I open the desktop browser. What is YouTube's philosophy on interface design? How do they actually organize the chaos of 3D creation?
The interface, as showcased by the YouTube Creators channel, is a masterclass in progressive disclosure. It doesn't overwhelm you immediately like After Effects does. The top bar is your administrative hub, project names, the incredibly vital autosave indicator, and the under-read states. But the two most critical components are the Effect Performance tool and the Change Layout toggle.
The Performance tool tracks file size and memory usage in real time, which reminds me of the old Spark AR limitations we talked about.
It's the modern equivalent, but much more transparent. It's essentially a budget tracker for processing power. Every time you add a growing particle effect or a high-resolution 3D mesh, that performance meter ticks up.
So it keeps you honest.
Right. If it goes into the red, YouTube's system will flag it, knowing that effect will crash a lower-end Android phone. It forces the creator to understand optimization. You can't just throw massive uncompressed files into the engine and expect it to run smoothly on every device.
And the Change Layout toggle allows you to hide the visual scripting panel, which I think is brilliant.
Oh, it's so helpful.
If I'm just making a vintage 35mm film grain filter, I don't need to see a massive grid of logic nodes. I can hide it, keep my workspace clean, and focus purely on the visual aesthetic.
It allows the software to scale with the ambition of the creator.
So the environment is set. Now we need to understand how the engine actually interprets the world. Because augmented reality requires the computer to understand physical space. The tutorial makes a very firm distinction between the two core building blocks of any effect: objects and assets. If we are explaining this without relying on a boring software manual, what is the conceptual difference?
This is the foundational hurdle for anyone moving from 2D video editing to 3D spatial computing. Let's step away from the software entirely. Imagine you are directing a stage play.
Okay, I'm with you.
An object is the functional role or the physical mark on the stage. It is the invisible instruction that says, a character stands here and they follow the lead actor. An asset is the specific actor you hire to wear the costume and stand on that mark.
Oh, that makes perfect sense.
Yeah.
The object is the behavior and the location. The asset is the visual representation filling that role.
Yeah.
So if I want a pair of digital sunglasses to track to my face, the head tracker is the object.
Right.
It's an invisible anchor point that the software mathematically locks to the bridge of the user's nose. The actual 3D file of the sunglasses, the mesh, the textures, the reflection data that is the asset.
Exactly. You attach the asset to the object, and once they are combined, you manipulate them in three-dimensional space. The interface uses standard transform tools, move, rotate, and scale. But what's happening mathematically is a constant recalculation of a 3D matrix. You are moving things along the x-axis for left and right, the y-axis for up and down, and crucially, the z-axis, which is depth, moving closer to or further from the camera lens.
To really ground this, let's dissect the first case study provided by the YouTube Creators channel. It's a tutorial on how to build a space alien effect. I want to walk through this because it perfectly illustrates how complex mathematical operations are hidden behind really simple sliders.
It's an excellent starting point because it manipulates the environment, the user's color palette, and their physical geometry without requiring any underlying logic or interactive scripting.
Right. So, step one, setting the atmosphere. The creator wants the entire world to look eerie and radioactive. They introduce a color filter object. On the screen, the creator just grabs a slider and pulls the tint to negative 100% green. The whole camera feed goes green. That seems basic, almost like an old Instagram filter.
It is basic color grading, basically shifting the overall hue. But step 2 is where the AR engine really flexes. We don't just want a green room, we want the human to become a green alien. So the creator adds a face paint object. Here is where they upload an asset. Just a simple, solid green square image.
Now wait, if I just paste a green square over someone's face, they look like a green cardboard box. The software has to know how to wrap that square around a spherical human head, and it has to retain the lighting so it looks like actual skin. How does it do that?
Through a mathematical function called a blend mode, specifically one called multiply. When you set the green square's blend mode to multiply, the software takes the numerical color value of every pixel in the green square and literally multiplies it by the numerical color value of the corresponding pixel in the live camera feed of the user's face.
Because white is mathematically treated as a 1 and black is a 0.
Precisely. So the dark shadows under the user's eyes or the bright highlights on their cheekbones dictate the final outcome. The shadow multiplies the green, making it a dark green. The highlight multiplies the green, making it a bright green.
Wow.
The flat square perfectly adopts the lighting and texture of the human face beneath it. It's a computational magic trick that takes milliseconds but results in a highly photorealistic skin alteration.
Okay, the skin is green, but the bone structure is still too human. This brings us to the stretch tool. When the creator activates this, the software overlays a mesh on the user's face. It looks like a digital wireframe mask.
That wireframe is the visual representation of the machine learning model hard at work. The AR engine is constantly running a facial recognition algorithm that identifies specific semantic landmarks, usually about 68 distinct points on a human face. It knows exactly where the pupils are, the corners of the mouth, the arch of the eyebrows, and the ridge of the jawline.
And because it maps those points, the creator can just click on the digital points near the eyes and drag them outward. The software recalculates the pixels between the landmarks, stretching the video feed like digital putty.
It's so fluid.
You pull the eyes massive, shrink the nose, drag the chin down to a sharp point. You are warping the user's anatomy in real time, and it tracks perfectly even when they talk or blink.
Next, the alien needs appendages. Antenna. The creator adds a face accessory object.
And the specific instruction here is that the uploaded asset, the image of the antenna, must have a transparent background, a standard PNG file. Because if it was a JPEG, you just have a white rectangle with green antenna floating on the user's head, which completely ruins the illusion.
Right. You position the transparent PNG above the wireframe head. Because it's parented to the head tracker object we discussed earlier, the software locks its coordinates to the user's skull. When the user tilts their head, the matrix recalculates the position, and the antenna tilt with them seamlessly.
So the alien is built. But if I'm filming this in my messy kitchen, the illusion is broken. We need to put this alien on Mars. This brings us to the body segmentation tool, which is arguably the most impressive leap in consumer-grade rendering.
Oh, without a doubt. If you bring up segmentation to any veteran visual effects artist, they will likely visibly cringe because the historical predecessor to this is rotoscoping.
I've done it, and it is a unique form of torture.
It really is.
For anyone listening who hasn't done it, if you wanted to cut an actor out of a background before green screens or machine learning, you had to use the pen tool to draw an outline around their body. And then you had to advance the video one frame, adjust the outline, advance another frame, adjust the outline. At 24 frames a second, isolating a 10-second clip took days of agonizing manual labor.
It was soul-crushing work. But in Effect Maker, the creator simply clicks a button labeled Add Body and Background.
And it happens instantly.
A neural network. YouTube's engine contains an AI model trained on millions of images of human beings in various poses and lighting conditions. When you activate body segmentation, the algorithm analyzes the live camera feed frame by frame, instantaneously predicting the boundary between human and not human.
That's incredible.
It creates a dynamic, moving silhouette mask, cuts the user out of their messy kitchen, and drops them seamlessly onto whatever background asset you uploaded in this tutorial, a cartoon landscape of Mars.
It accomplishes in milliseconds what used to take a human being a week. And it doesn't live on a constantly moving subject. But before you push this out to the world, you have to verify the illusion holds up. How inclusive is the testing environment?
This is a critical component of modern AR development. If you only test the effect using your own webcam, you only know that it works on your specific skin tone, facial structure, and lighting environment.
Right, which is a huge blind spot.
To solve this, the preview window includes a view video toggle. It provides a library of pre-recorded models exhibiting diverse ethnicities, genders, facial hair, and accessories like glasses. You can cycle the effect through all these models to ensure the machine learning mesh doesn't break if someone has a heavier beard or a different eye shape.
And my absolute favorite feature, the live device preview. You click a button, a QR code pops up on your desktop monitor, you scan it with your phone, and the YouTube app instantly opens with your unfinished effect running live on your camera. You can walk around your living room and test the tracking latency in the physical world.
It creates an incredibly tight, satisfying iteration loop. You tweak a value on the desktop, glance at your phone, and instantly see the result.
Now, the Space Alien is a fantastic demonstration of spatial manipulation, but it is fundamentally a static effect. The user just looks at the camera and they are an alien. If we look at the broader culture of short-form video, static effects have a very short shelf life. If you want true virality, if you want billions of views, the effect must be interactive.
It has to react to the user.
Yes. It needs to be a game or a quiz or a randomizer.
Which means the effect requires a brain. It needs logic. And this transitions us into the most intimidating yet most revolutionary aspect of modern AR creation: visual scripting.
The word scripting usually implies opening a text editor and writing lines of syntax. And we discussed how Snapchat's Lens Studio relies on JavaScript. If you miss a single semicolon in JavaScript, the entire program crashes. The code refuses to compile, and unless you know how to read debugging logs, you are completely stuck. That syntax barrier keeps brilliant visual artists from building interactive experiences.
Effect Makers circumvents the syntax barrier entirely through a no-code philosophy. They utilize a node-based architecture.
So if I have zero background in computer science, how do I conceptualize a node?
Think of a node as a discrete, specialized machine in a factory assembly line. Each machine has one specific job. It has an input slot on the left side where it receives materials and an output slot on the right side where it passes the modified product to the next machine.
Okay, I can picture that.
Instead of typing instructions, you are literally using your mouse to draw a wire from the output of one machine to the input of the next, creating a visual flowchart of logic.
The tutorial categorizes these nodes into distinct families. Let's decode them, not just as a list, but as an anatomy of a program. You start with triggers.
Triggers are the sensory organs of the effect. They wait for an event to happen in the real world. A trigger node could be listen for the user tapping the screen, or watch for the user opening their mouth, or detect when the user smiles. Until that specific physical action occurs, the rest of the logic chain remains entirely dormant.
Once a trigger fires, the signal often moves to logic nodes. I think of these as the brain's decision-making center.
Exactly. Logic nodes evaluate conditions. They are the crossroads. A logic node might ask, is the score currently greater than 10? Or, is the digital hat currently visible? It assesses the state of the digital world and routes the signal down path A if the answer is true, or path B if the answer is false.
Then you have control flow nodes, which feel like the conductors of an orchestra.
They manage time and sequence. If you want an animation to loop infinitely, or if you need to ensure that action X finishes completely before action Y is allowed to start, you route the signal through a control flow node to govern that timing.
Math nodes are pretty self-explanatory. They are the calculators. If the user catches a digital apple in their mouth, the math node takes the current score, adds 1, and outputs the new total. But the nodes that actually affect the visual reality are the objects and properties nodes.
These are the muscles. The signal finally reaches them, and they execute a change. They alter a 3D model's scale, change its opacity to make it invisible, or spin it around.
To see how these abstract concepts combine to create a viral sensation, we have to look at the second case study provided in the sources, a tutorial by the AR creator Louise Royer. She demonstrates how to build a mood check randomizer.
The randomizer is the undisputed king of short-form interactive formats. What Disney character are you? Which fast food item represents your soul? They tap into a fundamental psychological desire for personalization and slot machine-style variable rewards.
It's the digital equivalent of a magic 8-ball, and everyone loves them. So how does Louise construct the logic for this without writing code?
She begins by establishing the assets. She designs 15 different images, each displaying a different textual mood, like dramatic AF or main character energy. She uploads these into Effect Maker not as individual pictures, but as an image sequence. This object acts like a digital flipbook capable of rapidly cycling through the images.
She also uploads a static title image that just says mood check. She attaches both the title and the image sequence to a head tracker, so they float persistently above the user's head like a cartoon thought bubble. But without logic, that flipbook is just endlessly, uncontrollably flashing through all 15 moods at light speed. It's chaos. We need to build the assembly line to control it.
She opens the visual scripting canvas, step 1, the sensory organ. She drags a tap trigger node onto the workspace. This node constantly listens for the user's finger hitting the glass of their phone screen.
When the user taps, the first thing she wants is for that mood check title card to disappear, clearing the stage for the randomizer. But she doesn't want it to just vanish instantly in one frame. She wants it to feel cinematic and polished. So she draws a wire from the output of the tap node to a transition node.
The transition node is specifically designed to manipulate properties over time. She configures it to alter the title's opacity. It starts at a value of 1 fully solid and transitions to a value of 0 fully transparent. But the key is that she sets the duration of this transition to 0.8 seconds and applies an easing curve.
Easing is one of those tiny details that separates amateur motion graphics from professional ones. Instead of the fade happening linearly, fading at the exact same rigid speed the entire time, the easing curve makes it start slowly, accelerate in the middle, and gently decelerate at the end. It mimics the physics of momentum in the real world.
It creates a subconscious feeling of quality, so the title gracefully fades away. But how do we execute the actual randomization?
She draws a second wire from that same tap trigger, branching the signal. This wire heads toward the image sequence object to tell the flipbook to start playing. But she intercepts the signal by placing a delay node in the middle of the wire.
This is the stroke of genius in the logic design. She configures the delay node to hold the signal for a random time between 3 and 6 seconds.
Let's trace the causality of that, because the psychology it creates is brilliant. The user taps the screen, the flipbook immediately starts furiously cycling through all the moods. Meanwhile, the delay node acts as a hidden countdown timer, picking a random duration. Let's say it randomly chooses 4.7 seconds. For those 4.7 seconds, the user is staring at themselves, watching the options blur past, feeling the anticipation build. The slot machine is spinning.
The tension is entirely manufactured by that mathematical delay. And the moment that random 4.7-second timer expires, the delay node finally releases the signal down the wire. It hits the image sequence with a pause command. The flipbook freezes instantly on whichever image happened to be rendering on that exact millisecond.
Dramatic AF. The user laughs, the video records, they post it to Shorts, and their audience taps the filter to try it themselves. You have just engineered a self-replicating viral loop, utilizing complex variable timing and property transitions, and you accomplished it by connecting 4 visual boxes with a mouse.
The abstraction of complexity here is profound. 10 years ago, building that exact interactive loop required a software engineer who understood memory allocation and syntax debugging. Today, it requires a creative director who understands human psychology and basic cause and effect flowcharting. It empowers pure artistic intent by removing the burden of translation.
It is the ultimate democratization of logic.
Okay.
We've built a masterpiece. We have a beautifully optimized, visually scripted augmented reality experience sitting on our desktop. How do we unleash it onto a platform with 200 billion daily views? The final phase is publishing and policies, and it is not a free-for-all.
The submission mechanics are straightforward but require strategic marketing thinking. You initiate the process via the submit portal, and the first required asset is a thumbnail.
And it must be a perfectly square 1.1 image. This isn't just an administrative requirement. This is your packaging. When a user opens the effects tray in the YouTube app, they are confronted with a grid of hundreds of tiny square icons. Your thumbnail has to instantly communicate the value proposition of your effect at a glance.
The guidelines suggest using a high-quality screenshot of the effect in action or designing a custom graphic. Next is the metadata, the name and the description. This is purely for search engine optimization. If you name your project Randomizer Final V3, nobody will ever find it. You must name it something highly searchable like "What's your mood today?" quiz, so the YouTube algorithm can index it accurately.
And crucially, because we built an interactive effect using visual scripting, the submission portal prompts you to select instructions. This is a standardized UI overlay that will pop up on the user's screen when they select the effect. If your effect requires a tap to start, you must select the tap the screen instruction. Otherwise, millions of users will just stare blankly at a static title card, think the effect is broken, and swipe away.
User experience design doesn't end when the logic is built. You have to guide the participant. Once you hit submit, the effect does not go live instantly. It enters a mandatory review phase. In your creator dashboard, the status will read, "In review."
We talked earlier about the aggressive friction of requiring a government ID to keep bots out, but humans are perfectly capable of creating terrible or malicious content. What exactly is the review team, or the automated review algorithm, screening for?
The policies are strict and fall into 3 main categories for rejection. The first is technical stability. If your visual script contains an infinite loop that causes the app to freeze, or if you completely ignore the performance meter and uploaded a 50 megabyte uncompressed 3D mesh that crashes older phones, the effect will be rejected for performance issues. YouTube will not allow your creation to degrade the stability of their core application.
That protects the platform's reputation. What's the second category?
Violative or harmful content. This is the application of YouTube's overarching community guidelines to the AR space. The effect cannot contain hate speech, explicit imagery, or promote dangerous physical activities. If a filter encourages users to perform a hazardous stunt to trigger a visual reward, it will be pulled.
And the third is essentially false advertising.
Yeah.
Misleading metadata.
Exactly. If your thumbnail is a beautifully rendered image of a golden crown, but the actual effect just applies a heavy blur filter to the camera, it will be rejected for deceiving the user. They demand parity between the packaging and the product.
If you clear those hurdles, the status flips to active and you are live. If you fail, it flips to needs revision, and YouTube provides a diagnostic report on what policy you violated so you can adjust and resubmit. And what's incredibly exciting is that this isn't just theoretical anymore. The gates have opened.
The source material from LensList highlights the vanguard, the first wave of approved creators emerging from the closed beta.
It's a fascinating cross-section of the AR community, and their initial launches prove the versatility of Effect Maker. Let's look at a creator named Eddie and Third. They launched a slate of effects including Ring of Fire, Black Swan, and Echoes. Just analyzing the nomenclature in the creator's handle, it's clear they are utilizing the platform to push high-end spatial graphics. They are likely using complex particle emitters and intricate 3D meshes to create deeply immersive, visually striking environmental modifications.
Contrast that with another creator highlighted, Game+40, who launched Bucket Roller Coaster.
That immediately screams interactive spatial gaming. They are probably utilizing the gyroscope and accelerometer data of the Zone, combined with complex visual scripting to turn the user's physical environment into a digital amusement park ride. It's less about making the user look pretty and entirely about gamifying their physical space.
Then you have creators focusing on the core mechanics of short-form virality. The Infotainer released Dogi-Jin, which appears to be a highly polished character replacement mask, and Funny Ring Patience Game, which is a direct deployment of logic nodes to create an interactive challenge that viewers will want to try and beat.
But the effect that perhaps best encapsulates the modern internet is from Varun Raikar, who published Video Call with Meme Dogs. It is brilliant because it doesn't just flex technical capability, it deeply understands the cultural language of the platform. It places the user in a simulated social interaction with recognizable internet iconography. It is engineered from the ground up for shareability.
If we pull back and look at this vanguard through the lens of our earlier discussion, the catastrophic shutdown of Meta's Spark AR, the strategic brilliance of YouTube's timing becomes crystal clear.
The vacuum.
Yes. LensList is effectively the town square for the professional AR community. By actively courting and highlighting these specific creators, YouTube is signaling to thousands of orphan Spark developers that a life raft exists. These aren't amateurs learning what a timeline is. YouTube is absorbing battle-tested veterans. They are acquiring a workforce that already knows how to optimize polygon counts, who inherently understand the flow of visual logic, and you've spent years studying the psychology of what makes a filter go viral.
It's a massive talent acquisition, executed without paying a single salary. They're populating their new ecosystem with top-tier content on day one, ensuring that the effects on Shorts are immediately competitive with, if not superior to, TikTok and Snapchat. It is truly wild to step back and contemplate the trajectory we've traced in this deep dive. We started by discussing engineers in the 1960s constructing 30-ton steel centrifuges to fake zero gravity. We talked about technicians locked in darkrooms for months, mathematically synchronizing the light of dual projectors just to put a spaceship over a matte painting. We analyzed the terrifying exclusionary complexity of legacy software like After Effects, where the interface itself was a barrier to artistic entry.
And we have arrived at a technological reality where a verified creator using nothing but a standard internet browser on a consumer laptop can drag and drop a few logical nodes and instantaneously distribute a bespoke, interactive, spatially aware reality distortion to an audience generating 200 billion views a day. The compression of time, cost, and complexity is unprecedented in the history of media.
And the momentum is only accelerating. The Tube Filter reporting notes that we are already on the precipice of the next major paradigm shift. Generative AI integration directly within Effect Maker. Soon, you won't even need to build an asset and external 3D software. You will simply type a prompt, generate a photorealistic 16th century iron helmet, and the AI will generate the 3D mesh, paint the textures, map the light reflections, and attach it to the head tracker object in seconds.
Furthermore, the economic model is poised to shift. Tube Filter points to the high probability of direct monetization within the YouTube ecosystem. If YouTube decides to implement a revenue share model for AR developers that mirrors their massive partner program for video creators, it will completely eclipse the relatively modest creator funds of their competitors. It would legitimize AR development not just as a marketing tool for brands, but as a primary, highly lucrative career path for independent digital artists.
As we wrap this up, I want to return to where we started. I want to leave you, the listener, with a concept to chew on. We opened the show talking about the comfort of an X-ray, the security of an objective, shared reality, the idea that a broken bone is an undeniable, universally visible fact.
We rely on that shared baseline to function as a society. We assume that what I see is fundamentally what you see.
But as these node-based tools become infinitely accessible, as the syntax barrier completely dissolves, as AI begins hallucinating flawless 3D assets on command, the line demarcating physical reality from augmented reality is going to vanish entirely. And it's not just going to be funny alien faces on a phone screen. We are moving toward a world of wearable AR glass, where these environmental overlays and real-time world alterations become our primary interface with physical space.
Which introduces a profound and somewhat unsettling philosophical dilemma regarding human perception.
Exactly. If every single person possesses the frictionless capability to look at the physical world through their own custom-built, highly personalized digital algorithm, what happens to our shared reality? If I am walking down a city street looking through a digital filter that renders the architecture as a neon cyberpunk dystopia, and you're walking down the exact same physical street looking through a filter that renders it as a serene pastel 16th century watercolor, are we even inhabiting the same space anymore?
We are simultaneously democratizing boundless creativity while potentially designing the ultimate, inescapable digital isolation bubbles. The technology connects us to the tools of creation, but it might fundamentally disconnect us from a shared human experience.
It's the ultimate paradox of the digital age. Something to think deeply about the next time you tap your screen to spin a randomizer, and the fabric of your reality seamlessly changes color. Thanks for joining us on this exploration. Keep questioning the interfaces placed in front of you, keep examining the logic behind the illusion, and above all, stay insanely curious.